As a physics student, there are 4 kinematic equations which you need to know and how to use them. And that is what I'll be teaching you in this video. So the first equation is V equal to U plus AT. The second is V squared equal to U squared plus 2AS. The third one is S equal to UT plus 1 over 2 AT squared. And then the fourth one is S again, then V plus U into brackets multiplied by time divided by 2. Now, each of the variable in these equations has their own meaning. Okay, so we have V as the first variable here. V here stands for final velocity. In some textbooks, you may see something like this or even V2. They all mean the same thing, never mind. And then the second is U, which is initial velocity. That is the starting velocity. Starting velocity. Again, in some textbooks, you may see something like this, VI or even V1. They all mean the same thing. And then we have A. A here stands for acceleration, which is change in velocity per unit time, acceleration. And then we have T, which is the time taken to complete the motion. Okay, so acceleration can also be change in velocity divided by time. Okay, now how do we use these equations to solve some problems? So let's look at the first example. A car starts from rest and travels at uniform acceleration until it attains a velocity of 30 meters per second. After 6 seconds, the distance covered is dashed. So we are looking for distance. It's not given. The initial velocity, which is U, is 0 meters per second because it starts from rest. And then the final velocity is giving us this, 30 meters per second. And then the time at which it takes to reach this velocity is giving us 6 seconds. Now we have written out the parameters that we have in this question. The challenge for most students is to decide the right equation to use to solve this type of problem. Now that we have written out the parameters, now let's look at these equations. We have V, final velocity is given. We have U, of course, we have A in this equation, but we don't have acceleration yet. So we cannot use this equation, yes. In second equation, we don't also have acceleration, though we can find acceleration using this, but it is not direct. So we are not going to use it at the same time. In this equation, we also have acceleration. Then we cannot also use it because we don't have acceleration in this problem. And the last equation is the appropriate one because we are looking for distance. We have the final velocity. Here we have the initial velocity as well, and then we have the time taken. Mind you, we can use this equation, but we need to use this equation first to find acceleration. But this is the most appropriate equation. So all we need to do now is to substitute this data into this equation. So we have our S equal to final velocity, which is 30 plus the 0 multiplied by the time t, this one, divided by 2. And then this we cancel this, we are having 3. So your distance is going to be 30 plus 0 is 30 multiplied by 3. Now we are having 90 meters as the distance. So this is how to apply this equation. In most videos to come, I'm going to solve more examples teaching you how to apply each of these equations to solve different problems. Thank you for taking your time to watch this video. Please do like it, share it with more students, and if you're not following this page, endeavor to do so for more updates. Goodbye.